This is 2.3, Part B, on dividing polynomials through long division. Before we begin polynomial long division, we want to just have a quick reminder of how long division works with numbers. So first, if I want to divide 15 into 3,981, the first thing I would do is find out how many times 15 went into 39. I would check 3 first, but then go to 3, so I check 39. 15 goes into 39 twice, and 2 times 15 is 30. Your next step would be to subtract. So you'd have 39 minus 30 is 9, and then you would bring down your next digit. That's the 8. You would try again, and you'd ask how many times does 15 go into 98? So you would count that up. It goes in 6 times, because 15 times 6 is 90. And once again, you would subtract. And when you finish the subtraction, let's see, 98 minus 90 is 8, and you would bring down the next digit, which is 1, and so then you would try to find how many times 15 went into 81. That would be 5, because 15 times 5 is 75, and if you subtract 81 minus 75, you get 6. Okay, so the 6 would be a remainder in long division. And you could conclude that, let's see, that 265, that first of all, the quotient of 3,981 divided by 15 is 265 plus a remainder of 6 over the original divisor of 15. So that would be how I would write the solution. The remainder is over the divisor. Now, actually, with this one, I could reduce it, right? So you would say 265 plus those reduced by 2, so 3/5. Sorry, they reduced by 3, so 2/5. Divide by 2, divide by 2, 3/5. Divide by 3, divide by 3. Let me do this one more time. Divide by 3, I get 2. Divide by 3, I get 5. There we go. That's my final answer. 265 plus 2/5. Okay? And so, if you want to check in your calculator just to kind of verify, you would do 3,981 divided by 15, and you could check 265 plus 2/5, and they come out to the same decimal. Perfect. Now, I need to transport this same technique in these long divisions. I'm going to practice one of these just so I could remember the process, but it's going to look a little different. I'm going to start with the thing I'm dividing by outside the long division bar. So I've got x minus 2 outside and 5x squared minus 7x minus 6 on the inside. Okay, so some similarities. When I work on my long division problem, I don't look at the entire inside originally. I look at just the first piece I can get that value to go into. So look at just this first piece, 5x squared. I'm actually only going to look at the x right here and say, what do I have to multiply x by to get 5x squared? So it's going to have to be 5x, right? Because 5x times x is 5x squared. Now, I'm going to multiply, just like we did up here. When you said 15 went into 39 two times, then you did 2 times 15 is 30, and you subtracted. Okay? So I multiply, so that gives me 5x times x is 5x squared, and 5x times 2 is negative 10x. Then you subtract. And when you subtract, you get your next term, but when you subtract, you have to really make sure that you distribute that negative through to both terms. That's a kicker on these long division problems. 5x minus 5x is 0. Negative 7x minus negative 10x will make that plus 10x. So I've really got negative 7x plus 10x is 3x. Bring down the next term, minus 6. Then we do it again. What do you need to multiply x by? To get 3x. This time it's going to be 3, positive 3. Distribute again. So 3 times x is 3x. 3 times negative 2 is negative 6, and subtract. Don't forget, while you're subtracting, to distribute that negative. So you've got 3x minus 3x, that's 0, and 6 minus negative 6, or 6 plus 6 is 0. This one has a remainder 0, so it went in evenly. So the answer is 5x plus 3. Now, if you wanted to check that, you could check it by multiplying the answer by what you divided by and seeing if what you get is the thing that you were dividing into. So let's check that 5x plus 3 times x minus 2 is really equal to 5x squared minus 7x plus 6. So it would be 5x squared minus 10x plus 3x minus 6. So you can see you do get 5x squared minus 7x minus 6. So that checks. Multiply them together, you get the number or the polynomial expression back. Okay. Let's do our long division again. In the next one, we're going to be dividing 4x minus 1 into 12x squared minus 23x plus 5. So first, what do you need to multiply 4x by to get 12x squared? It's going to have to be 3x. 3 times 4 is 12, x times x is x squared. So that gives you 12x squared minus 3x if you distribute that. Subtract. Don't forget to distribute your negative. If I distribute the negative, 12 minus 12 is 0. 23 minus negative 3, that's 23 plus 3x, gives me negative 20x. Bring down the plus 5. Keep going. What do you need to multiply 4x by to get negative 20x? This time it's negative 5. So negative 5 times 4x is negative 20x, and negative 5 times negative 1 is positive 5, and we subtract. We subtract because that's how you work with long division with the regular numbers. It's how you work with long division with the polynomial. Negative 20 minus negative 20, distribute that division, is positive 20 down here. So negative 20 plus 20 is 0. 5 minus 5 is also 0. So once again, this one went in perfectly. And the solution is just the 3x minus 5. Look at the back side of our page. 2 more problems to look at here. In the next one, I have 2x minus 1 divided into 6x cubed minus 11x squared plus 2. So I actually don't have an x term, so I'm going to actually write in a plus 0x. I always want to keep check of every single power of x decreasing down to 0 and I hold its place so I know where to add my like terms, right? So we've got x cubed, x squared. There aren't any x's in my 2. Okay, so write in a placeholder for that missing value. Then we divide. What do you need to multiply 2x by to get 6x cubed? 3 to get 6x needs to multiply by x squared to get x cubed. Distribute. 2 times 3 is 6, then x to the third. X squared times negative 1, so it'd be negative 3x squared. Subtract. Don't forget to distribute that negative. So negative 6x, that negative will make that negative negative, so positive 3. 6 minus 6 is 0. 11 minus negative, or 11 plus 3, will add, negative 11 plus 3 will add to negative 8, x squared. Bring down your next term, which is 0x. Okay. Repeat. What do you need to multiply 2 by to get negative 8? That had to be negative 4 and another x. Negative 4 times 2, that's negative 8. X times x is x squared. Keep distributing. 2 negatives make that positive. 4x. Subtract. Negative 8 minus negative 8, that's negative 8 plus 8, that's 0. And then we have 0 minus 4, that's negative 4x. Plus 2. One more time, you can divide 2x into negative 4x by multiplying by negative 2. So that's going to be negative 4x. And then negative 2 times 1 will be plus 2. Once again, when I subtract, negative 4 plus 4 is 0. 2 minus 2 is 0. So last time, I also got a remainder of 0. The answer is 3x squared minus 4x minus 2. We have one more of these to try. This time we're going to divide x squared plus 3 into 3x cubed minus 4x squared plus 9x minus 16. There were no missing terms in there. Power 3, 2, 1, 0. Okay. What do I need to multiply x squared by to get 3x cubed? It's going to have to be 3 and x. 3x times x squared, that's 3x cubed. 3x times 3, that's 9x. I'm going to write that one over here because that's underneath its like term. There's no x squared term. We're going to combine. 3 minus 3 is 0. Bring down this term in the middle. There's nothing to add on to it. Then you have 9 minus 9 is 0, and you're going to bring down your end. Okay. Bring down your new term also. Okay. Now, what can you multiply x squared by to get negative 4x? Well, negative 4. Negative 4x squared, I mean. So it's negative 4x squared, negative, and a positive make this negative 12, and we subtract. Okay. Negative and a negative make that positive. Negative and negative make that one positive. So we've got negative 4x squared plus 4x squared, 0x squared. Negative 16 plus 12 will be negative 4. Okay. I can't divide x squared into 4x because it doesn't have any x. The power got reduced enough that I can't divide it in anymore. So this is going to be my remainder. If there was still a number of x's where I could multiply something, but I can't reduce the number of x's I already have by multiplying by any polynomial function. So my answer has to then be the 3x minus 4 plus the remainder. But the remainder is negative, so we're actually going to say minus 4 over x squared plus 3. It's the remainder over the divisor. And that's the end of the section.